Measurement errors, part 2. So, in part 1, I spoke a little bit to how measurements can go wrong. This one is considerably deeper if you go into it. But it has to do with the numerator and denominator and what those mean, and why it's important to carry them and know when to carry them. This, I think, is the biggest hole, I suppose, is when you drop the numerator or the denominator to an answer, you lose information about what you're answering. And this is very well used because the nuance of losing the denominator I'll get into. So I was going to get the MyPad out and a pencil and write this down, and I've been thinking about what to say. Again, this is 201, right? The second day of conversation. So the numerator and denominator just matter, but let's go through our simples here. 1 plus 1 equals 2. Okay, we can find exceptions to that rule, but that's a pretty good rule, but it's not absolute. But 1 plus 1 equals 2. If I have 1 apple plus 1 apple equals 2 apples. So for the apples, I can lose the denominator, or this is the numerator in this case, right? Because it's 1a plus 1a equals 2a. So if I just say I have 2, and I can see apples, then I think I'm answering how many apples do you have question to the cashier, right? Now, I've got 3 apples and 7 oranges. So 3 plus 7 is 10. It's 10. It's actually not 10. That's not the answer. I can't do that. I either have to say something like it's 7 oranges and 3 apples, or I can say it's 10 pieces of fruit. So now I have a new numerator. I have 10 pieces. I have 10. I have 10 pieces of fruit, but that fruit is 7 oranges and 3 apples. So in a conversation, it's important. If you have fruit you're offering, or if you have 10 apples you're offering, or if you have 10 oranges you're offering. So that sounds simple. Let's go to the next part here. Miles. If I say 50 miles, that's a distance. If I say 50 miles per hour, that's a speed. Neither of those have directions. So I'm either saying I'm something 50 miles, or we're going to go this fast. But miles per hour doesn't say how far I'm going. It only says how fast I'm going to go to get somewhere. I could go half a mile, or I could go 1,000 miles. So those simple things we take for granted in speech, carry those out into physics. Carry that out into a simple closed system equation. PV equals T. Pressure times volume equals temperature. If I have a tire that's not flat and I put air in it, it doesn't usually get much bigger. So that equation, pressure times volume equals temperature, for a fixed volume, if I add 50 psi, right, that's pressure, I add 50 pounds of pressure, so I went from 50 to 100, but my volume didn't change, my temperature had to have changed. So if you don't remember all the factors in that equation, you can forget what you were talking about. If I was going to worry about that equation, I would have to know coefficients of expansions, because the temperature change can change, well, it does change the equation, right? If you change the temperature, PV equals T, P is, or V is constant. If you change T, something on the other side of the equation has to change. So knowing that equation and where it's applied and how it's used is implied kind of in, you have to know about it, right? Do you worry about that for your car tire? When you put pressure in the car tires, you pull up this PV equals T equation? So no, the answer is no. You don't need it. So you don't need it. It's not something you have to worry about in your general life, but in commercial industrial life, in a mechanic's life, right? Cylinder head pressure, water pressure, all these things can matter. You can blow hoses off, you can blow a spark plug out, you can not have enough compression and it won't start or won't stay running or idles rough. So there's a PV equals T where you can start to think about it. You don't have to solve the equation, but you have to know the other variables in there, right? You've got high pressure. The volume's constant in the motor, pretty much. So the only other thing that can cause the pressure to change is temperature. So the motor's got to be running hot to boil the water hotter, or the thermostat is bad in the car. So, but still the mechanic didn't apply the equation, he just kind of knew about it and knew that he was looking for a pressure or a temperature problem, and not the temperature was causing the pressure, because the volume is pretty much constant. Now, if you want to talk about the steam coming out of the hose in the radiator, that's a steam now. It's no longer a liquid. You're getting into some pressure physics here. So why this slow path about a numerator and denominator? And if you let a person talk past the numerator and denominator, it allows the conversation to go off in the wrong direction. Now, whoever's presenting the argument might not even be aware of PV equals T, PV equals nRT, but he knows how to put 60 pounds of air pressure in his car tire. So these are extrapolations. These are things that come from knowing possibilities. And the best way to know possibilities is through understanding reality. And it gets complicated. So who do you trust in here? I never met a dishonest professor. I went to a lot of education. Formal community college and business related for decades. So it is, I was exposed to these ideas and able to use them, and maybe the idea helped frame how I saw something. And I'm speaking to, a professional career, but you do this in the grocery store. What's your favorite? How do I pick which corn? By price, or by color on the label, or by brand name? These are so soft negotiations in your head. You don't need to think about the It's not logic, it's a decision tree process that you think is logic, but there's variables all across that you've turned into a will I buy this can, yes or no. So, do I have a taste for this? Can I eat all of this before it goes bad? Can I afford this on my budget? So, you begin using and worrying about, your money. That's critical for me. Every penny. You start worrying about your health and wondering which direction that's going. And it's all real. It's all real. That's part of the physics of life. So, this was number 2. Gentle talk about numerators and denominators, and some forethought in their importance. And it's a difference between 10 oranges and 10 pieces of fruit. It's a difference between millibars and PSI. It's a difference between Roentgen and sieverts. It's a difference between weighing your ingredients or doing volume measurements of your ingredients. And if you're just skilled, you can see the flour might be moist and you need a little less or a little more. Actually, you don't even do that. You feel it when you're kneading the dough. So the next hand throw is half a throw or double a throw when you're working on the dough. These are all subconscious things that you go through. These are the decision trees of life. And it's an organic thing for every decision that you do, and yet you do it. You own the decisions. You usually make the mistakes. Forgiveness is a blessing. Real forgiveness comes from within. Carry the denominator.